So remember this test was only 10 questions, and these are the last two problems. So it says find the vertical and horizontal asymptotes for, and then they give us a rational function. So rational functions, we have to worry about the asymptotes. Okay, to find the vertical ones, you take the denominator and set that equal to 0. Now in this case it factors into x minus 5 and x plus 2. So that means there are two vertical asymptotes, one at x equals 5 and one at x equals negative 2. So those are the two vertical asymptotes. To find the horizontal asymptote, it goes by the degree of the numerator. So degree of the numerator, which is 2, and the degree of the denominator. Remember, these are polynomials, so the degree right there, which is also 2. Now, because they're the same, so if the degree of the numerator is less than the degree of the denominator, then you get y equals 0 for the horizontal asymptote. This is the time when there were 3 cases. If the degrees are equal, then you take their coefficients. So like if you have axn over bxn, whatever's over here, but you get y equals a over b. That's the line, okay? Now that's our case here, because we have the same degree, so they're equal, and you have a 1 here and a 1 here. So y equals 1 over 1, or y equals 1. That is the horizontal asymptote. Okay? And the other case, well, I kind of out of room, but the other case was if the numerator is greater than the denominator. Then there's no horizontal asymptote. But if the numerator is equal to the denominator plus 1, so if the numerator is just 1 more, then you get an oblique asymptote. And we did that in class, but unfortunately it didn't make the cut for the test. But anyway, I just wanted to go over those things for you. Okay, you didn't have to put any of that on your test. All you had to do was put the answers for the vertical and the horizontal, those 2 boxes. Okay, but now in number 10, we want to graph it. So we know a vertical asymptote is going to be at 4. So x equals 4. That's a vertical. 1, 2, 3, 4. Okay, and then because these are the same degree, we know that we have a horizontal asymptote at y equals 3 over 1, or y equals 3. So a horizontal asymptote, let's see, right there. Now, from there, you're finding points. So maybe I would plug in 0, find f of 0. And I would get negative 6. You know what? I'm going to erase my drawing. Oops, because I can't read it anymore. Okay, so I'm going to get, if I put in 0, negative 6 over negative 4, which is what, 3 over 2, 1.5. So 0, 1.5, it's like right there. And then maybe I would put in like 2, find f of 2. And that would give me 6 minus 6 over 2 minus 4. But you know what? I should have set the numerator to 0 and I didn't do it, but that's going to happen at 2. So the zeros are when the numerator equals 0, which is right there. And then that says, okay, this is doing something like this. And I only get 1 0. So, and it's at 2. So we just figured that out. Now, I would probably find some more points. Like maybe I would find f of 6. So let's see what that looks like. If I put in 6, I'd have 18 minus 6 over 6 minus 4, which is 13 over 2, 6.5. Okay, so 6, and then let's see, 4, 5, 6.5. It'd be like right there, maybe. And then maybe I would put in 8, f of 8. I'm trying to, because it's an odd function and it's symmetric about the origin. Now the origin's shifted. It went over to the right 4 and up 3, but I'm expecting some symmetry here. So about that, about the new origin, I guess, if you think of transformations. So that's why I'm picking these numbers. You could choose other numbers. So what's 8 times 3? 24 minus 6 over 8 minus 4. So what's that? 24 minus 6 is 18. And divided by 4? That doesn't seem right. Maybe I did something wrong. I don't think so. Okay. So what's that? 4.5? 4.5? Okay, so let's do that. 8 and 4.5, like right there. Yeah, it looks pretty good. It probably comes down a little lower. But again, these are rough sketches. And so that would be enough. That's the graph.